I don't know what to do. We need our intro, is what we need. But hi, boys and girls, weather report. Five waiting. Oh my God, we're just killing it today. Is Gur and James? Do they have a stream by right now? By the way, by any chance? Let me check.
I don't know.
Oh shit. Okay, I was hearing myself. Sorry.
I didn't get a notification.
Let's see if I got any notifications. We got Anton Petrov. We got Dylan missed call. Okay. Answers in Atheism is live.
Good for us.
And let's see who else.
Hawk says no. I don't know if he's responding to what you said.
What'd you say? I missed that.
He just said, Ox said no. So I'm guessing he meant like no one else is streaming right now.
Oh, okay. Why am I not seeing chats? Oh, there's my chats. Hi, Willie Durant and Command Cyclor and Ox. Our loyal listeners, the people that actually show up. The rest of you people are going to lose your rent if you're late. But they can't hear me because they're not here. So my threats fall on deaf ears. Is that?
I know it doesn't fall on any ears.
No ears.
There's no ears to fall on.
We're without ears.
If you guys aren't here, say hello.
Yeah. Yep. So, you got anything today, Andrew?
No, not really. Not right now, at least.
So let's see if I can talk a little bit about the thumbnail I used today is from this illustration right here. I'm gonna have to show my camera.
I don't see anything.
You don't see now, do ya? Do you now?
Yep.
Okay. Anyway, this is the Echinoderm, and it shows the first I think a 16 cell stage in the upper left on A. Might be 16. It looks like 16. And what happens is it's already forming these micromeres at the bottom, and the micromeres are what create the gut and the skeleton of this little guy. But then it becomes a free swimming larva that looks like this on the bottom. So that's when it's created its little spicules and stuff. But anyway, this is from a paper which is called by Shashikant 2018 from Genome to Anatomy, the Architecture and Evolution of the Skeletogenic Gene Regulatory Network of Sea Urchins and Other Echinoderms. So when I said that, Scott, did your eyes glaze over?
No, you said words that I remember you saying before.
Okay. I just want to check. I don't want people's eyes glazing over on me, because this is important shit. Okay. So anyway, but from the top to the bottom, that cell comes from the mother or the zygote. That basically the fertilized zygote or the egg actually has a polarity to it. So it's a cell with polarity. A lot of cells have polarity. And where did that polarity come from? Well, it comes from the genetics of the cell. And then basically when it's fertilized, it already has a certain polarity that determines where the butt's going to be and where the head is going to be, right? So that's the case in Drosophila and humans and a whole bunch of other stuff. So there's already like a gradient of proteins across the cell from the top to the bottom. And that happens basically, let's see, I'm trying to think. I think it's in mice, for instance, how the egg is kept in the mother and how it breaks off and develops basically has a polarity to it. So there's already a polarity there, but that comes from the mother. And then when the egg starts to divide, it's using maternal mRNA and proteins that come from the mother. So it's not yet using the fertilized genome, the genome for both the mother and the father. But within the first maybe 5 cell divisions, somewhere in there, the genes basically from the actual organism itself, from the mother and father, will turn on and start to take over. So that's where the rest of the organism starts to develop. And and then the other thing that comes from the mother is every cell has a sugar code on its surface, basically. And those are things called glycans, which is a fancy word for a sugar, various kinds of sugar that are attached to proteins and are attached to the lipid membrane of the cell. And they have a really complicated code that they've been calling the sugar code. Okay. And those come from the mother. But then within 4 or 5 cells, the cells are creating their own sugars, and that comes from the genome of the mother and father. And the original sugar code comes from the genome of the mother. So it's still coming from the genes. There's no basically sugar code inheritance. So I don't know what the creationists are on about. And Jonathan Wells wrote a paper for a prestigious peer-reviewed journal called Biocomplexity, which is actually a sham journal set up to welcome intelligent design. So that's what Biocomplexity is about. It's a special journal, and I think maybe even owned and run by some creationist institute. I'm not sure what its history. But anyway, like, I will give them credit, that they're looking at intelligent design as science.
I found this on the web.
Shut up, Siri. I don't want to talk to you right now. God, I'm always fighting with my Siri. So, we saw a license plate out shopping called.
I'm sorry.
And it was seriously with SIRI. Seriously, a custom license plate. That was kind of fun this morning.
Yeah, this might be a good time whenever we do a weather report to put your watch on a charger. As far as your phone, I don't know what to do other than put it in a drawer.
I'd have to put it in like a vault. So I had my phone, some paper towels, a couple of letters, and a bunch of other stuff up on the counter. And Snack jumped up on the counter, slid across the counter, knocked my phone, the papers, the paper towels on the floor, and then he jumped down and ran downstairs. Little devil. He is a monster. And he's looking at the Christmas tree from his cat hotel, which is about 12 feet away. And he's thinking, I could jump onto that thing. I could do this. He's horrible. I don't know what I'm going to do.
He's just going through what every little kitty cat goes through around Christmas. Yeah, look at that boy.
This is him trying to rip Dylan's robe off.
Oh.
Well, you got to think about it. There's going to be more and more robots in kitty cat's future.
Yeah.
They got to try to fight them off.
Robots and robots. Okay. Anyway, so Sal Cordova is absolutely confident of a few things, and so are a bunch of other creationists. And we'll talk a little bit about that. I invited Dr. Dan and Dr. Thompson.
Yeah.
Okay.
Nice if Dr. Thompson shows up. I'd like to talk to him again.
Yeah, I kind of wish this whole thing would show here. That would be nice.
Oh yeah, it's cutting off some of it to the side.
Yeah. Yeah, and let's see if I can fix that. Yeah, it's kind of fixed. Not entirely fixed. A little bit on the left is still not showing up. Yeah. I don't know what to do about that. Who knows?
It's a large regulatory network.
Yeah, so let's see if I can make this a little smaller. And that ain't working. Why ain't that working? Why ain't that working? I don't understand. Oh, I know why.
What does this particular network specify? Or
this is the echinoderm development, basically.
Right, but like what's developing specifically? Is it just in general, or is it a specific part of the body, or
starting from the mother at the top, Okay, this
Oh.
is one of those gene regulatory networks. And there is a program, and I forgot the name of the program, where you can create these things yourself, these gene regulatory networks. But I'll try to explain it a little bit. I'm just trying to make my window smaller first.
I'd be interested in looking at those. Interesting.
Yeah, it's a neat little program. Okay, let's see if, okay, we're not, okay, we got most of it. We got just about all of it. We're doing okay. Okay. So anyway, starting at the very top, there's beta-catenin and left TCF and OTX come from the mother, basically. So this is the like beta-catenin turns on Wnt8, or basically, and then Wnt8 is transcribed. So if you look at the top, I'm not sure how much you could see, but basically an arrow pointing down to something means it turns it on. It expresses that gene. Okay. Then a little crooked arrow or a bent arrow that goes up and then over to the right. Okay, like you see on the Wnt8, that means it's transcribed. That means that cell is expressed, right? And that may go somewhere, but in this case, Wnt8 doesn't. Wnt8 basically, what is it? Wnt8 is a membrane messaging, transmembrane message receiver, basically, that keeps beta-catenin from being killed, and then it ends up accumulating in the nucleus. But there's a whole lot of details here, but you can see that. So what happened is Eric Davidson and let's see, Isabel Peters and a number of other researchers, you and a whole bunch of other people got together, and they created these massive gene regulatory networks for the echinoderm. And they traced out a lot of it, but there are still some questions, some things that we don't quite know how some things are expressed or how they end up in the cell. But for the most part, they have a whole lot of the skeletogenesis of, how the skeleton develops in an echinoderm. And this is what it looks like. These are the gene regulatory networks. Every one of those words there is either a gene or a function. In this case, they're all genes. But like you could have an arrow pointing down to limb development, right? And, and with this program, let me see if I can find this program for us. Hang on a second. Program.
No, I suppose is the way their like a starfish arms develop, is that, I wondered, the same deep homologous pathway perhaps as limb development in tetrapods or other vertebrates? I'm not sure. That'd be interesting to look at.
Yeah, there's
I'm sure it didn't go back that far, but it'd be interesting if it did.
Yeah, I think it is. I think it does use, it definitely uses the beta-catenin Wnt pathway as part of the development. But then I don't think, I think it's pretty separate from there on. But we could look at it because I have all that detailed in another PowerPoint somewhere. Why can't I find program? Oh my God. Oh, what did I call it? And I just wrote it just recently. Hang on a second here. Let's see. Yeah, let's see, development. I should have the name for that thing. It's a pretty cool little program. There's Echinoderms.
Oh, the one you can make your own network out of?
Yeah, yeah. Let's see. Further development. Dev tutorial, Barisi, Icaros.
By the way, Nestle has a question down there for you, Speed.
Oh, did you see the recent message from me and Des? Yes, I did. I did respond. I was supposed to get to it today, but we were looking at that Smith video, I think it was, and we're supposed to do a stream on it. So, but I've been remiss in checking it out. Let's see. Here's papers. I got papers up the butt. I got a lot of papers. Wind family.
Papers and papers.
Yeah.
Paper after paper.
Yep. Paper after paper after paper.
As a certain someone would say.
Standing for truth. Here's some stuff we did from the other day. So I have some videos I could show. There's a whole bunch of stuff to dig into here, and I'm going to end up hopefully saying enough that it will start to make some sense, maybe at some point.
Yeah.
I don't know where it is.
You're trying to give little pieces at a time, basically.
Yeah. Well, there's one way. There's one way that we can.
Hey, Nestling has more for you to read here. So he says, no, that was yesterday. There are more responses that we sent today.
Well, you don't expect me to keep up with today, do you? I mean, that I'm kind of a yesterday kind of guy. So
also, what's the problem called that you can make your own network?
What's that?
He says, also, what's the problem called? Maybe he means program.
Hang on a second. Biocodes. It's called Biocodes, and I have a link to it somewhere. And let me see here. Escape. Gotta get out of that. Out of spotlight.
AG from SideChat.
Biocodes. I think it's called Biocodes. Anyway, that's the one. Biocode, applied biocode, biocodes, learn informatics. Maybe it ain't. Let's see. GRN program. Maybe it ain't biocodes. Maybe it's something else. I'll have to look it up. I think it's in my other PowerPoint. Do I dare? Yeah. Do I dare load 2 PowerPoints? And I just had it running. Let me see here. Hang on a second. It's gonna drive me nuts if I can't find it. Where's the DMG? Oh. You guys are supposed to be talking and filling space here.
Oh, I was just hearing some echo. Oh, no, it's gone.
So we're supposed to be talking. So Andrew, tell me about what are y'all planning to do for Christmas dinner?
Let's see. We celebrated early Christmas for one side of my family, and actual Christmas Eve, I think, or I know it's this Saturday. We're gonna celebrate it for the other side of my family. So. But as for the specific stuff for like eating or whatnot, I have no idea. Probably the usual stuff for Christmas.
Here, I put my email in the side chat in case anybody wanted to send me one of those Amazon gift cards you can do in an email.
Okay, I'm hearing some feedback here.
Yeah, there's a lot of noise going on.
Really?
Yeah, I wonder if are you backmasking something?
No, we got the same problem. Let's see. Does this cure it? How about that?
Right now, I don't hear that background noise.
Okay, so I got to shut that off. So let's see. So the other reprogramming, program.
Double Dare dueling coaster. Wow, something to put your drinks on, and it's interesting to see how it's a double dare. Someone might need to mute a tab. Who knows what the problem is?
I know it's not me because I just muted myself and I'm still hearing it.
Are you still echoing?
I'm just getting some staticky noise from you, like when you just talked just now.
Really?
Yes.
Yeah, it has to be on your end.
It did. You did it again.
Shit. So,
Paleologos, happy holidays.
Yeah, I don't know what to do about that. I can shut some things down, and how is it now? How bad is it?
It's pretty
bad. Same as it was.
Yeah, so we're ending up
the same as it ever was.
We're ending up with exactly the same problem that I had before I started using Firefox. So apparently, but then I need Firefox because StreamYard's no longer working with Chrome, and this just sucks. This just all sucks.
Yeah, my problem is
on the plus side, you sound better now.
My Chrome has turned out to be very unreliable, like on YouTube.
Yeah.
I just can't do anything on YouTube without it making me to a Hoops page.
Yeah. Anyway.
And now I'm getting a background noise kind of echo.
Yeah, I'm hearing something now.
Yep, I turned Firefox back on. But there's a reason for that. Let's see if I can play a clip and have it work. Okay, I'm going to play this and just listen to what they say, what the creationists are saying. How bad is the noise?
Right now, I'm not hearing you.
Oh,
Okay. Okay.
when we speak, I guess.
Let me know what the quality of the video is.
Okay.
Okay.
Yeah, no, well, let's suffice to say, I'm in.
What is the quality?
Sounds okay.
Okay. Okay. Now this is Sel and Emery talking. They actually let Emery graduate. He must have lied on all the answers to all the tests because he doesn't believe in any of the answers that he wrote down. But he got a master's in biology. So he studies plants, I believe. Okay, here we go.
Full agreement that there are things that can be inherited non-genetically. You can have.
Okay. What can be inherited non-genetically? What is it about an organism that is non-genetic that you could say is non-genetic?
Right.
I don't know what they're talking about, but let's see what else. This runs for a little while.
We know that the sugar code is inherited non-genetically.
No, we
and
don't.
It can be modified across generations.
So
No. There are inheritable traits. So as far as the population model of just changing.
Okay, that's the first piece of bullshit. Okay, here's the other one. This one is that.
Is that like an older video?
Yeah. No, that one's just a couple days ago. So
wow,
5615. Okay, so listen to they're talking to Sygart now, and this is from 3 months ago. So listen to this one.
Said, oh, we have to talk, and we're like, that's a really great reaction when I start to nerd out. So I'm going to throw out one other thing that I think is important because it's been circulated in the ID community, and it's also in the evolutionary, the third way. So this is really one of the rare instances where it's like their interest in this. It's non-DNA inheritance. And there's several levels of it. It's not what we would call epigenetic. That's, for me, epigenetics means chromatin modifications.
Good on you, Sal.
So the non-DNA inheritance is the glycans or the sugar code. And why don't you say something about that? And then we'll talk. The other one is cortical, where there's organelle membrane inheritance. So I'm just throwing out some other stuff, and I figure you'd be interested.
Yeah, I've heard of the sugar code, but I know almost nothing about it because this all developed, well, after I retired. So you'd have to tell us more about that.
Okay, so anyone can look up the sugar code. One of the problems with it's not like DNA that's linear. I mean, somewhat linear, and you can read it. With sugars, you need a specialized different machine to read each because it's 3-dimensional shapes. But sugars can contain 3 times more information than the DNA. And so there's been questions. It's like, well, where does all the developmental information come from? So we could have the same, you can kind of see it that every cell has the same DNA, but in a human, it has the same DNA, but it can express in so many different ways. And I remember when I was asking, how does the DNA know how to have all these post-translational, all these chromatin modifications, like when I was seeing these things of these embryos develop. And my professors at the NIH were some of the researchers into the histone code. And so I said, where does it all do that? And they said, no one knows. Where's the information stored?
Okay, enough of that shit. How's the audio, boys and girls?
it's just as staticky.
Yeah,
You got
it's
another way to
Well, I could try to get out and come back in, but the last time I tried that, I couldn't get back in. So I'm going to try. And you may end up hosting the show. So,
Oh my goodness.
I don't know.
Well, I don't see any avatar for Nestle, but he has joined the show.
Wait a minute. There is no option to leave the studio.
What?
So you're trapped.
Yeah, there's only an option to end the stream.
I wonder if
So
Nestle's having trouble with his.
Man, we're just having all kinds of technical difficulties today.
Let me try something else here.
Oh, there's a sex bot in the side chat.
Oh, good.
I just killed it.
Oh,
thank you,
no. We like them. Hot girls here. Hot girls here. Hot girls here.
Oh, you wanted that? Okay, I'm sorry, man.
I mean, there are, what the hell's wrong with that, man? It's a good advertisement for the stream. Hot girls here. No. Yeah, you can blast them because they are bots.
But
Yes, those bots.
And who would ever clicking on one of those links has got to be one of the worst experience. I mean, that way lies doom.
I've
heard stories of people
on bots when I know it's a bot.
I've heard stories of relatives who have basically ended up with some pretty bad shit on their home screen and just, oh my God.
Yeah, I told my 80-something-year-old uncle for the 100th time that he had a virus problem that he wanted me to fix for him. I told him, the safest thing you can do is turn off this computer and throw it through that window right there.
Throw it away. Yeah, exactly.
You'll never get a virus again.
Yeah. This an unnamed relative basically was, just looking for porn like a normal kind of guy, guys and girls look at porn. And he was clicking on links and they took over his browser and his home screen and they put stuff on there that was not what he was looking for at all. It was the kind of stuff that basically where your wife packs your clothes and throws them out on the lawn.
Throws you out the second floor window.
And every time you turned the computer on, and his wife was coming home in like an hour, and every time you turned the computer on, this thing popped up, and he was just like, "Oh my God!" And I went and reproduced it and found out how they were sticking it in the operating system, and basically it was a Windows problem back in Windows 7 days, right? It was pretty amazing.
Are you with us now, Nestle?
Yeah, are you with us?
Can you hear me now?
Yes.
Oh, I use a different browser than Chrome.
Oh.
Okay. So you can use Chrome, but we can't. Whoa, what just happened?
Me? I just wiped
everything just went dark for me.
I know. I got dark. It got dark in here.
Okay. You popped up to the top, so never mind.
Yep. So these gene regulatory networks, what I wanted to show is that they're number one. These are the programs they talk about because there are AND gates and OR gates and there are NOT gates, right? If you see a line coming down, a vertical line coming down onto a gene, if it has a bar, that means it represses that. If it has an arrow, that means it expresses it. And then you'll see a bar coming up and going to the right, and that means that it's expressed, that gene is going to end up in the cell. And you can see how all these networks become very complicated, and that's how cells differentiate. Well, the creationists, let's talk about the creationists.
Bill Gates.
Jonathan Wells, who is a PhD from Caltech, and I guess had written some papers in his youth. Let me see here if I can find Jonathan Wells. Okay, so here's what it says about Jonathan Wells. John Corrigan Wells, born 1942, is an American author, theologian, and advocate of the pseudoscientific argument of intelligent design. Wells joined the Unification Church, those are the Moonies, in 1974, and subsequently wrote that the teachings of the church founder, Sun Myung Moon, his own studies at the Unification theological seminary, and his prayers convinced him to devote his life to destroying Darwinism. What the fuck? I mean,
yeah, destroying Darwinism, that thing that hasn't been a thing for almost a century.
Mission accomplished.
The term Darwinism is often used by intelligent design proponents and other creationists to refer to the scientific consensus on evolution. That's what they mean. They don't really mean Darwinism. He gained a PhD in religious studies at Yale University, and I thought he had a PhD in biology. Oh, okay. Churches then became director of the Unification Church's Interreligious Outreach Program organization in New York. In 1989, he studied at the University of California, Berkeley, where he earned a PhD in molecular and cellular biology. What kind of a student do you think he was? Kind of like Emery Moyna, sitting there disagreeing with everything the teacher said and learning enough to pass, to basically...
just passing the test. If I guess if you need the credentials to be a disinformation conduit, then that's the way to do it. Get your religious training, go get your science training, and then go back and lie for your religion, or at least misinform or misinterpret things, kind of like Sal does.
Yeah. So 1989. So he was what, 47 years old when he got his degree in biology. So how much has he actually contributed to biology? So anyway, he wrote this paper.
I'm sure he cares about science so much.
Yeah. So he wrote this paper, membrane patterns carry ontogenetic information that is specified independently of DNA. Okay, no, it ain't.
Complexity, is that an ID website? Or is it an actual scientific journal?
Biocomplexity is an intelligent design journal designed to allow intelligent designers to get their papers published. So,
just a second. This is a journal by Discovery Institute.
Hold on, guys. Can you guys handle the show here for a minute? I got to step away.
Sure. All right. What were you going to say, Nestle?
This journal is just the Discovery Institute.
Okay, yeah, so they're coming up with
staffed, and it's the staff. It's just
there we go.
Oh yeah, we have our own peer review process where we peer review ourselves.
Yeah, just basically trying to divert people who already believe anyway to their information so they can feel like they have scientific grounding.
Mm-hmm. Also, this title, this was already known for a long time. I think it's the membrane, the structure of the phospholipid barrier that is not made by DNA directly. Like with a bit, it's a bit difficult to explain, but it's a more how should I put it? Like the cell without the phospholipid bilayer to exist, the cell doesn't know how to make a phospholipid bilayer. It just the structure is always inherited from the previous cell. It's made by DNA. The cell, the membrane itself is not made by the DNA. And I would be surprised that some patterns on the membrane, whatever that means, is also not inherited directly from DNA. Mm-hmm. So yeah, it's DNA is not everything DNA is not everything about biology. It's more than that, of course.
What are you thinking about it, Andrew?
Andrew. Sorry, you're talking about phospholipids. I was listening, but also reading the side chat. Sorry.
Oh, okay.
I'm maybe trying to read the abstract, but it's a very
it's
blurry.
Kind of small. Font there.
Let's see. Maybe we can make it bigger.
I uploaded it up a bit and I can read it. The abstract embryo development should be embryonic development, I think, but whatever. It depends on developmental gene regulatory networks, but the developmentary gene regulatory networks depend on pre-existing spatial anisotropies that are defined by early embryonic axes, and those axes are established long before the embryos. Developmental gene regulatory networks are in place, are put in place. For example, the anterior-posterior axis in Drosophila and the animal. And that is already that's been already known for long that the signal that defines the body axis is pre-imposed by a bicoid, I think, if I'm not mistaken. In the case
By
of
what?
Drosophila,
By what?
bicoid.
Yeah, bicoid, right? That's one of them, and then there's caudal, I think. There's basically a network, but it starts out with some
a
polarity.
Signal external. Yeah.
Right. It starts out with polarity in the maternal cell, which is from the genetics of that particular species, right? I mean, it's part from the mother, and it kind of goes back a few generations. But the sugar code and that basically that gradient in the gamete is always specified by DNA eventually. Ultimately, DNA is what you're going to modify in order to change these things. And DNA is what you're going to modify in order to respond to those changes. So if we have a lot of bicoid on one end of the egg, basically that bicoid is going to operate on the DNA. It's going to do some epigenetics, some chromatin remodeling, and it's going to do some repression or expression of a gene. And ultimately, it is the gene that is going to determine the cell shape. And now the maternal genes are active for the first few cell divisions, and then they quickly get phased out. But it's all genetics from there on. As to how the organism forms is genetic. And now the sugar code.
No, not really. Like it. I think I've also brought this up how many streams ago. I don't remember exactly when, but I've seen an argument where if you measure the genome size and you calculate how much information, theoretically speaking, in the whole genome can contain, it contains less information than the whole organism during development. So most of the information of development emerges out of physical interactions between the components, not from the DNA itself.
Oh, right. Yeah, physics. Basically, the genome, so that is the same as the nature versus nurture question, right? It's not a dichotomy.
No, that's a different thing that I'm
very similar, because basically your genetic code is there, and that is going to determine what proteins are expressed and what proteins are repressed, and ultimately the protein content of the cell is going to come from the genome. Okay. Now there's going to be a whole lot of physical effects developing the morphology of the organism, but it's a complete misunderstanding to say that is something that is inherited, and because inherited on a different line, and because it is inherited on a different line, therefore evolution is false. The genome mutations are still very, very important in the morphology.
Of course, the genome is part of the very important part of the process, but it's not the only part. Like for developmental processes, you need a lot more than just knowing what the DNA is about.
Well, you can make an argument that physics and stickiness and viscosity of certain, of water even is, definitely very important in the development of a cell. But
like one of my new favorite examples is like I think you've perhaps seen it before. Like if a wet mud dries out, the dirt contracts. You get these patterns of cracks through the earth, right?
Oh yeah,
you've seen that. It forms a distinct pattern, but the pattern is not quote unquote encoded. It's just the physical interaction between the material. And a similar process happens when it comes to the cracks seen in the face of a crocodile. the divisions between the cracks on the face of the crocodile, that's not encoded. It's just the way how these things crack according to physical stresses. A similar process.
It's an emergent property.
Exactly.
Yeah, it just goes back to the argument that the genome is not a blueprint. It's an interactive piece of material that interacts with physics and with the environment, and with the mother and with the history of that organism to create every individual, right? I mean, you can't pick out one thing and say this is the most important, but I think you could almost say that about the genome, because that is going to determine what the content of that cell is and how that cell organizes itself in the future. It's going to be the genome. Now, what they're saying about the sugar code, basically sugar codes, he goes on and talks about it. Okay, here's a picture of a sugar attached to a protein, basically. And these sugars can branch out in remarkable ways. But the branches, the way they branch, if they branch specifically, that comes from a gene that basically glycosylates or say glycan onto that protein in the endoplasmic reticulum. So there is, genetics at work there in how these sugar codes are created. And then they end up shuffling through the Golgi apparatus to the surface of the cell. And some of those things are what viruses recognize or what viruses have on their surfaces. That's how the immune system recognizes stuff. And, it's all with this complicated code. But they've kind of gone nuts with this idea of sugar code and histone code, right? These are all further mechanisms in the cell. But at the heart of it all is that nucleus generating proteins from that genome. And I would say that if you're going to pick something out as being primary, it's going to be the genome. Because if you modify that, you're going to modify that sugar code. If you modify it, you're going to modify the chromatin organization. You're going to modify the histone code. These guys seem to think that there's some other line of information that's flowing through life. And they're right and they're wrong, okay? They're right in that, yes, physics, the fact that we live on the earth, the fact that it is the temperature it is, the fact of carbon chemistry, all of that stuff is definitely integral to life. But you can't say that, that's like the genome and evolution is wrong because mutation doesn't change the organism. Hell, it don't. Mutation.
I think it's always completely independent of the genome when it isn't.
Yeah. I think it's some other secret code that, God put in there that they're going to decipher. And it's just like,
the code.
I would say it depends on like the example that I gave regarding the cracks on the face of the crocodile. I would say that is completely dependent of the genome.
Well, that's physics. Yeah, it's physics. Yeah. Okay, that's if you take a genome and put it into outer space, it is not going to develop into an organism.
Oh, right, of course, yeah.
And if you took even if you took a zygote and put it in outer space, it would not develop into an organism. Even if it had oxygen around it, if it didn't have gravity, you'd probably end up with a very, very different kind of organism or a failed organism, something that would die. So, I mean, that's what, but they're seizing on.
It's fun you mentioned gravity because it's a very interesting thing. Like the type of mineral that we use to build our bones. It has a very, very peculiar property because if you apply stress in one direction, the mineral will build itself to withstand that stress in that direction. So it's self-reinforcing basically without any need of an external signal.
Yeah, I don't think I'm not sure how a baby would develop in 0G.
So if you are living your entire life in 0G, your bones will be weak because of that. Because it doesn't experience the stress you experience in a gravity well, like on Earth.
Yep. So here he says, clearly the information carrying capacity of the glycome far exceeds the combined capacities of the genome and proteome. They call it the glycode or sugar code. Well, yes and no. basically sugars can like the complexity of sugars would be greater than the genome, obviously, because we only have four nucleotides, right? And the sugar code, there are dozens and dozens of different sugars and glycosamines. A glycosamine is a sugar kind of crossed with a amino acid, if you could think of it that way.
Hey, real quick question. When he says it has been called the glycode or sugar code, who's he saying is calling it that?
The researchers that basically fell upon it. That's
Are these legitimate researchers, or are they?
Can you scroll down?
Yeah.
Can you scroll down to reference 165 to 169?
He's probably talking about. Let me see here if I can.
If you can scroll down to the references to 165.
He's probably talking about Gabius or Gabius or whatever. Let's see. Okay, cat. I don't need a cat right now. I love you, Loki, but
because if it's the same author popping up again and again, that's a bad sign. If the same.
No, this is Lane. This is Lane. Let's see, 165, and what were the other numbers?
62 to 69.
Yeah. Okay, this guy right here.
Gabius. Cummings.
Yeah, that's these are legitimate researchers. Gabius wrote a number of. Okay, this is Gabius's. What is the sugar code? Basically, from this is 2022, but he's written a number of papers on the sugar code, and he talks about it. Yeah, they do legitimately call it a sugar code. Here's a really pretty picture of it, of all the modifications, and you can see that the sugars are very complex. But the effect that these sugar codes have on things is not as detailed and as not as machine-like as they would like to think, right? These things form sticky surfaces, and sometimes they form surfaces that will, like one sugar code might stick to another one on a cell, or your immune system might be able to recognize a particular sugar or whatever, but it's not quite what they're going for. Okay, the vocabulary of the sugar code, and this is all legitimate.
Nothing in biology is really machine-like, unless you're talking about macroscopic organisms which have like joints, which you can describe as hinges. Like, except for those things, you can describe them as machines. But at the cellular level or the molecular level, you have the things work very differently than on our scale.
Yeah. Here's what is that? Galectin. Basically, this is just like one sugar and all the different combinations and things that you can have. So anyway, it allows for cell membranes to have a rich texture on them, right? A rich array of textures. Mm-hmm. And that's going to overall affect the operation of the organism.
So these scientists are encouraging us to eat more sugar?
I'm not sure I understand.
Did you hear that?
Apparently, I need to restate my question.
I guess so. I don't know. Yep, pretty pictures, pretty stuff. I got a huge fat book on glycochemistry, and so does Immutable. Basically, we've been looking at this for a while. It's pretty cool, actually. Oh, this is neat. What is this? Holy shit. Yeah, they're showing them selectin. You remember what I was talking about with cadherins the other day? Cells sticking together, Andrew? Is Andrew still with us?
Andrew bailed on us.
Oh, he had a bail. He
did a ninja bail.
Oh, ninja bail. Okay. Anyway, I was talking about cadherins and how cells stick together. And some cells will stick. Some cells will stick to their own kind. And sometimes cadherins are like, you'll have more cadherins of a particular type, like E. cadherin. You'll have more of them on one cell than you do on the other. And those cells will end up being in a shell around the ones that have the most, and the ones that have the most will be at the center. So there you have something that physically self-organizes depending on what's on that membrane, right? But what's on that membrane, those integrins come from the genome. So it's all connected to the genome eventually anyway. Now, I'm going to make a prediction, and I'm going to be dead before this happens. But in 20 to 50 years, we are going to be able to take these gene regulatory networks in embryology, and we're going to be able to take several extant species, and we're going to be able to go back and reconstruct the common ancestor. And we're going to be able to reconstruct its genome and its embryology and how it developed. And we're going to be able to draw a picture without finding a fossil of a common ancestor. And we're going to do that using AI and using the sugar code and the histone code and the genetic code and embryology. And we're going to be able to create machines that will basically go back and predict based on bioinformatics, comparing the genes, right? And what the genes do when they change these gene regulatory networks. And we're going to be able to go back and predict what common ancestors look like. That's where evolution is going. And we're going to do that with a couple of things. We're going to have soft body physics engines that gamers may be familiar with, right? Like every game that you play on the computer, the gamers are developing software that's going to be very important in science. Okay, they're developing physics engines. So they have an engine that tells you how a ball will bounce, or that, a bullet will go through something or not go through something, or ricochet off something, all of that stuff. What they need is a soft body physics engine with contortable bodies, like rubber balls that actually contort. And then we can start putting together cellular networks with these gene regulatory networks. And we're going to be able to predict what organisms look like. And it's going to be done with massive amounts of computer power, a little bit of AI, and a lot of biology. What do you think of that? You think I'm full of shit? So when I'm right, I want you fuckers to remember me, man.
You need to do a I predict YouTube video, and then like put the MP4 on a thumb drive and bury it, in a coffee can out in your backyard.
Yeah, I can see you guys. You remember Speed? He used to have that YouTube channel, and he
remember that old guy Speed?
Yeah,
he made some crazy predictions.
He tripped and killed himself trying to put his jogging pants on without leaning on something. Yeah, that guy.
But Peter, like the questions that you asked in the via email, we were wondering if you could such a stream either today or tomorrow for our discussion with Dessel.
The last thing I said is I will get to this tomorrow.
That's today. That's today. That's today.
Yeah, I said that today. I said, and then okay, you have a real long one, right? Okay, so that's okay. So origins of the ribosome, earliest polypeptides and proteins, the genetic code, and the eigenerror threshold, and the Darwin eigencycle.
Right? I will discuss that with Dessel, but I was wondering if you could host the stream between us two.
Yes, I will definitely tomorrow.
Or today.
Today is not happening.
All right.
Today's over. It's done for. Today's shot in the head. Yeah. We'll do one tomorrow. How about tomorrow?
Sure.
What time would you like to do it? Can you get a response from Dessel and try to figure it out?
Sure. Like I put my preferred timing. It's like the same time as now, maybe like one hour earlier. As of now, like right now, it's I think almost 6 p.m. in the Eastern Standard Time, I think, or something.
Yeah, it's 6 Eastern.
So 5 p.m. tomorrow then. So today or right now, 1 hour earlier or something.
Okay, 4 p.m. in the one true time zone, Central Standard Time, which is the one true zone, right? Yeah.
Maybe Dessel has another preferred time, but I will ask him.
Yeah,
to make sure.
try to work it out with Dessel so you both show up, and I'll just
Alright.
take a back seat and let you guys discuss it. So that would be cool.
Alright.
I'd enjoy that. Okay, so what else can we say? Soft body simulation. Ooh, Top Dog found something. Top Dog, why didn't you give me this a long time ago? I've been asking people for a soft body engine for years. Cool, soft body simulation. Let's take a look. Let's have a look at this thing, and then we're going to shoot her in the head. Oh, let's see, soft body simulation. Let me start my camera. Whoops, I got to start my YouTube. And there it be. Oh, no, I want to Chrome all. Okay, so there it is. So paper tutorials. Come on, go down. Don't get smaller. It's getting smaller. What the hell? That's cool. But that's not what I want. What the heck? Paper, squash. Oh, restart. Okay, run. Oh, nice. Yes. This is what we need.
What is this we're witnessing?
That's cool. It's probably a game engine for soft body simulation. It basically contorts soft bodies, and that's what you need for cells, because cells contort. Except you're going to have to add a lot of stuff, because the actin, the cytoskeleton of the cell, has a lot to do with its shape and how compressible it is, and filopodia and all kinds of stuff. So, but this is awesome. Cool. Stop. Yeah, that thing looks like it's in de-stress. De-stress. Yeah, I'll have to look at the paper. Thanks, Top Dog. I'm going to stick the link in my description just for the hell of it.
Gesundheitness.
Oh. Yep. So anyway, yeah. How do you avoid getting into that discussion, that nature versus nurture dichotomy parallel with the epigenetic code and the history, all of that stuff, when that's really, we're not saying, and we haven't been saying for a hell of a long time, that the genome is what creates the organism. It's the genome it's the very same discussion as what our mind is. Okay, our mind is not just our brain, not just neurons. It's our brain, our body, and the entire world around us. And you can't say one thing is the mind and none of the other things are. And nor can you say that the genome is everything. But we can certainly argue that the genome is pretty goddamn, pretty much a key player. Because if we modify one of those expression bits of DNA, we are going to modify the entire organism, or it's going to die or whatever. So anyway, there's got to be a way to talk about it that is sensible, so that you don't end up going down the alley that no, this and that, and people arguing with each other. And the third wave, what do they call it? The third wave, where basically the people from the third wave of evolution are basically saying something, as Dr. Dan would point out, that we already fucking know. We're already accounting for that, right? We're not saying that it isn't a part of it. So, I mean, you know what I mean? It's frustrating when people get into little nitpicky conversations about what's the most important, like air is the most important thing to humans. Is it? It's really key. It's a big deal.
Air versus blood flow.
Yeah, versus other humans, versus food, carbohydrates. I don't know. Fuck it all. Anyway, this has been a confusing broadcast from your friends at Answers in Atheism.
Just remember, there's a lot of things out there looking to kill you.
Yeah, like trying to put your jogging pants on without, a handrail.
This sounds awfully specific and awfully personal.
I
So I
speak-
bet you something happened this morning that you're really not going into detail about.
Well, not just this morning. I have this absolute insistence that I put my pants on and without leaning on anything or grabbing anything or sitting down. I have to do it by balancing. And I'm 72 years old. It's getting kind of scary. But anyway.
Well, you just need to wear a helmet. You know,
Yeah,
just carry a helmet around with you all the time. Sleep in a helmet.
I should sleep in it. Well, how do you know I don't?
I don't.
I have my Glocks, 2 Glocks, and a helmet. I don't sleep well.
I can see why not. Now, of course, where do you keep the Glocks?
Under my pillow. One of them.
Just sleep in the pillow next to it rather than the one.
No, I don't put it under the pillow I sleep on. I'm not a complete idiot. I'm just an idiot. I'm a partial idiot.
Partial idiot.
Yeah. And the other one's on
a marbled idiot.
The big Glocks on the nightstand, along with 9 clips. Yep.
In fact, you might want to wear knee pads and elbow pads along with that helmet.
Yeah, and body armor and yeah.
Something for the wrist too. Is there something that would let's say you did fall down? A natural thing is to land on the palms of your hands, which of course ruin your wrists. We've got to figure out a way to deal with that.
It's
a nice desk cat.
Say hi.
Yeah, you have a mouse on your desk and a cat on your desk.
Look at that tail.
That's
something.
You could paint with that tail.
That's an amazing tail. Hey, Snacker. Okay, I'm going to shoot her in the head.
It's time to shoot her in the head, folks. Time to head off into the west.
Okay, hang around for a second, Nestle. Okay.
All right.
Okay, we're ending the broadcast, and we don't have an outro, so it's going to end abruptly. I apologize for that. Thanks, guys, for showing up. Nerdy, Lucky, everybody. I wasn't paid. Oh, shit.
It's been great, y'all. That's what
It's
we're trying to
great.
say. You're the best side chat in YouTube land.
Yes, and I do read this stuff after the fact. So not always while I'm on stream. Okay, goodbye, cruel world.